Consider the following example where we're declaring a variable x to be of type double without assigning any values to it. Now, if you would write an if statement code with this based on this pseudocode, which says if x is equal to 10, do something, we will see a runtime error. But why such a runtime error occurs? The reason is that we did not assign a value to x. And as far as Swift is concerned, the value of x does not exist, and Swift does not know how to actually handle such a scenario. So it generates a runtime error. So the remedy for this problem is putting a question mark in front of the data type. So this declaration now reads that x is a variable of an optional double data type. When we declare x to be of an optional type, like so, without actually any assignment, Swift will automatically set that variable to be equal to this thing called nil, which effectively is saying that x is valueless, but by just setting it to nil, we're not leaving x up in the air. So x is valueless, is in a state which is recognized by Swift. So as a result, we won't see any runtime errors if we try to execute the if statement that I mentioned earlier. Once the declaration is complete, we could either assign a value to our variable, which has an optional data type, separately as we did before, or we could even assign a value to it simultaneously as we did before. But the important thing is that we should use a variable or a parameter of an optional data type if we can foresee that at any time in the future our variable becomes valueless. A very simple example of that would be in gaming, that when you actually you have some enemy ships and they could exist at one point, and at sometime during the runtime of the program, that enemy ship is destroyed. That does not remove the variables associated with that enemy ship. They'll stay in the program, but those variables are in a limbo status, and as a result, when the Swift tries to read their values, we will see a runtime error. So again, to repeat myself, an optional is used if at any time in the course of the program we can foresee a situation where the value for that optional parameter can become non-existent. The very last point to mention on this slide is once you have an optional parameter, the same way that we can assign a known value to it, we can actually assign the value nil to that parameter. by assigning nil to an optional parameter, we are actually saying that that parameter is in a valueless state, but that is the state that Swift recognizes. Now let us consider this situation that we have correctly declared an optional parameter, but then we wish to use the value of this parameter in another part of code. For instance, if we wish to assign a value to a different parameter in the code, which uses the value of the first parameter, something like this. If we say y is equal to x plus 1, if we do so, we will see a runtime error. Okay, so one might ask, why is that the case? Is it because x was not assigned a value? Okay, to see if that is the case, we actually assign a value to x at the time of declaration, but we would still see the runtime error if we try to execute this statement. The reason for this problem is that when we try to read the value of an optional parameter, if we just follow the ways that we are familiar with up to this point, the value of that parameter is unaccessible. In other words, it's wrapped. It's wrapped inside some wrapping that we cannot just access that value without opening the wrapping, without unwrapping it. In order to be able to access the known value of a parameter, which is of optional type, we have to unwrap it. To unwrap an optional parameter, we use exclamation point after the name of that parameter. So when we have x followed by an exclamation point, we are telling Swift that unwrap the value of x and then add it to 1, then assign it to y. So unwrapping is only allowed if we know that our optional parameter has a known value. If its value is nil, unwrapping will not be allowed either. We would still see a runtime error. So we only unwrap if we know that a given parameter, which is an optional, contains a value. It's not valueless. So as a result of unwrapping, y is equal to x plus 1 will result in 11.1, which is the expected thing, without any runtime error. So in short, if x is known to have a non-nil value, that is important. It has a non-nil value. Then that variable x in this case can be unwrapped. Its value can be extracted and can be used in the rest of the code. Without the exclamation point, unwrapping does not work, and the value of x will not be available to the rest of the code. The unwrapping process that we discussed earlier is called forced unwrapping, and that is the process of declaring an optional, and every time we need to read or access that optional, we use the exclamation point after it. So that is the terminology used in Swift for that is force unwrapping. We have another form of unwrapping, and that is implicit unwrapping. Implicit unwrapping is used when we know at the time of declaring an optional that its value is it's going to always be non-nil. Um, in such a case, we replace the question mark, which is used at the time of declaration of an optional, by exclamation point, um, resulting in a format like this, where we have a variable x, which is an optional, but by using the exclamation point, we are saying that x is implicitly unwrapped from the very beginning. So when we do this, the advantage would be that every time that we want to access this optional in the code, we do not need to do a force unwrapping. So it sort of saves us the time to just keep putting exclamation points after the name of an optional in the code. Apart from that, an implicitly unwrapped optional is exactly the same as an ordinary optional in every sense. We will be talking about implicitly unwrapped optionals and their use in Swift in the future tutorials in some more detail. Okay, I think now it's time to see some examples of optionals in Xcode. So let us start with declaring a variable without declaring it to be an optional, like so, and try to use it in an if statement. And you can immediately see that because we are not assigning a value to this variable, we see some runtime errors. The error here is saying variable y used before being initialized. So in other words, hasn't been assigned. So this is the error that I was talking about before. Now, what happens if we put a question mark in front of the data type here? You can see that the runtime error has been removed. Of course, because y is not equal to 10, the statements in the body of the if statement are not run. But we don't get an error because we are declaring y to be an optional, and although we are not assigning a value to it, we don't see any problems with that. Now let us actually assign a value to y and see whether the if statement actually runs. So if we assign this to be equal to 10, the print here should be executed, and we can see that it actually is run. Y is equal to optional 10. So it tells you in the run of the print function that this is an optional. The interesting thing is that when we run the print and we insert an optional variable inside the print message, Swift automatically inserts the word optional before the value which is being printed to indicate that it is printing an optional value. If for any reason we wish to set the value of an optional to nil, we can do so by just set it to nil, and that is perfectly legal. And as you can see here, Swift recognizes that and computes the value y to be equal to nil here. The next example to examine is the example of a situation where we try to access an optional which has not been set to a value. So if we declare a variable y1 of the type optional double, and then declare another variable y2 and try to assign the value of that optional to it, it does not work for the reasons I explained before. So the reason for this is the unwrapping concept that I talked about earlier, and it's not the fact that y1 has not been assigned a value, because if we do assign a value to y1, and then try to execute this statement again, still we have a problem. It says the value of optional type double not unwrapped. Okay, so that means a unwrapping is needed. So in order to solve that problem, we have to unwrap it. We put an exclamation point after y1, and here it is. We get the correct result. Okay, let's have a look at an example of implicitly unwrapped optionals. Here is an example. So we are declaring a variable called y3, which is optional, but it is implicitly unwrapped by using the exclamation point at the time of declaration. We are also simultaneously doing the assignment by setting y3 to the value of 10.1. So now we can write other statements in our code based on y3 without actually using any forced unwrapping of y3. So we can just say y3 plus 1. So you can see the result is here, and we managed to actually access the value of y3, add it to 1, and assign it to y4 without using the exclamation point after y3. We could insert exclamation point after y3 and the result would be exactly the same, but by doing by using the implicitly unwrapped optional at the time of declaration, we remove the need for using the exclamation point at the time of accessing that optional. The last topic of this second tutorial is optional binding. With optional binding in Swift, what we do is we first check and see whether an optional contains a non-nil value, and if that is the case, we assign that value to a temporary so-called constant or variable. Optional binding is used in conjunction with while loops and if statements. The condition of a while loop or if statement when used with optional binding is satisfied if the optional contains a non-nil value. The temporary constant or variable which is created will only remain available within the body of the if statement or while loop. This is effectively what is done in optional binding. So this is of course the example of an if statement. This could also, the argument here could also be applied to while loops. So what we are saying here is if x, which is an optional, is not equal to nil, then we declare a variable, a temporary variable called y within the body of the if statement and set it equal to the value of the optional, which is forced unwrapped. Then use this value of y within the body of the if statement or the while loop. Once we are done with it, we delete the value of y as if it doesn't exist, and then get out of the body of the if statement. This is effectively what is done in optional binding. Swift uses a shorthand for this, and instead of declaring the temporary variable or constant within the body of the if statement and deleting it like so, it just uses this very neat shorthand which reads as if variable y is equal to x, use y in the statements within the body of the if statement. Every time we see a syntax like this, if var or let a variable equal to an optional, then the way it should be read is shown here. Finally, it should also be noted here that variable or constant y, or whatever name that we're using here, is only valid within the body of if statement or while loop, and it loses its validity outside the body, as I'm showing here. So if we use y in a statement here, this would be outside of the if statement or the while loop, and it will not be valid, it will not be recognized. So it's as if y never existed. Let's quickly have a look at the topics we just went through in Xcode, and see what we should expect when we're dealing with optional binding. So before actually using optional binding, let's look at the expanded version of the idea of optional binding that I showed in the slides. Here we are having a variable called w, which is of type optional int, and we are assigning value of 20 to it. So the idea of optional binding is this, that we say if w is not equal to nil, exclamation point before the equal sign means not equal. So this is a not operator in Swift. So if w is not equal to nil, we declare a new variable called q, and assign it to the unwrapped value of w. Then we do whatever we want with this value of q. In this particular case, it's just a simple print function. And then finally we delete q. Of course, we do not have, in Swift, we do not have a delete function. I'm just putting it as a comment here to indicate that outside the body of if, q will not remain valid, so it's deleted here. So this is the idea of optional binding. The actual optional binding would be done for this particular case like this. We say if variable q is equal to w, where w is still an optional int. So if w is non-nil, its value is extracted and assigned to q. And once that condition is satisfied, in other words, if this is non-nil, we complete the print function, and the result is printed down here, which is exactly the same as the case above. To show that q outside the body of if is no longer valid, let's try to print this message again and see whether it recognizes q. And it does not, as expected. So the error reads use of unresolved identifier q. That means q is not recognized. This concludes our second tutorial. In the next tutorial, I will be focusing on some of the basic operations in Swift.